All right, good afternoon, everyone. Thank you for joining us today for Radon Is It Still an Issue with Jay Solomon. Today's webinar is part of our Everyday Environment webinar series, which is offered on the second Thursday of each month. My name is Erin Garrett, and I will be moderating for Jay today. This webinar is being recorded, and the recording will be shared to University of Illinois Extension's YouTube page. Please allow us several weeks for processing and closed captioning this recording. I will share the link to the YouTube page in the chat box if you want to save that for later or check out some of our other recorded webinars that we have available. And we will follow up with an email to you all once the recording does post in several weeks so that you know it is available. If you do have a question at any time during the webinar today, please feel free to type it into the chat box. I will be moderating the chat and keeping track of questions to ask Jay at the end of the webinar. So once again, thank you for joining us. And Jay, I'll go ahead and turn it over to you.
All right, thank you, Erin. I appreciate the opportunity to present this. Talking about radon, is it still an issue? And that's, as I look back at my history and doing this, it is kind of a question whether it is still a history or an issue or not. I turned my camera on here to start with, but to save a little bandwidth, I will stop it now since I've introduced myself. So what I want to try to cover today is a little bit of what is radon and a little bit about the history, and that's the reason for asking the question. Some of the things about the health implications of it and how radon enters our home. We'll talk a little bit about that piece of it, and then indoor radon measurement and how you go about getting the measurement, knowing whether you have an issue in the home or not, and then radon reduction systems would be the last piece we talk a little bit about. So many of you may have heard about radon, and it's a topic that's been out for many years. The short version is radon is an indoor air pollutant. It is colorless, odorless, and it's a radioactive gas that comes from the naturally occurring uranium in the soil as part of that breakdown of it. Radon is the first gas in the breakdown chain, is generated from that trapped uranium as part of the decay process of uranium. So that's where it comes from, and we really can, as others have pointed out in the past, we can really thank the Canadians for that, in that one of the larger uranium concentrations initially was up in the Canadian area, what is now Canada, was pushed down into the United States by the glaciers. So a little bit about the history of it, and to answer that why are we still talking about it piece here is radon was known to be an issue in mining as early as the early 1900s. And they knew that was one of the things that was in the mines that was causing some of the health problems for miners. Indoor air quality, it became an issue in indoor air quality in 1984. I mean, that's when it really hit the news, and really people started really considering it. And it really comes back to basically one individual in the group, and one individual and his experiences. Mr. Stanley was a new employee at the Limerick nuclear power station while it was being built. And upon entering it, coming from his home to go into the plant while they were under construction, he was setting off the radiation alarms. And this was prior to there being any nuclear products on the facility, and as I say, coming inward. So that really raised some alarms and brought the right group of people together to start wondering and start investigating why this was a problem. They took the equipment to his house in their investigation and found that his house measured 2,700 picocuries per liter in the air in the home. So fairly significant. And basically they were able to say, okay, this is where the radon, this is where our alarms are going off at, where the decay products are coming from. In his case, it really was the case that brought radon up to the national attention public attention and the US EPA. So a little bit about it in Illinois. The Illinois Radon Industry Licensing Act was enacted in 1998, and that basically required individuals to required individuals providing radon measurement or mitigation services to be licensed. It had to do with making sure these individuals knew what they were doing, and prior to that, there were instances where individuals of knowledge have been able to go back out and look and see installations that had not been done correctly or been basically fraudulently done. So that's the industry actually helped drive that. It became part of the real estate, the Real Property Disclosure Act came right after that in 98, 99. It required the disclosure basically in a real estate contract. I'm aware of unsafe concentrations of radon in the home was what had to be disclosed. In 2008, that act was moved forward a little bit with the Radon Awareness Act, where there was a mandate to disclose the radon risk and the measurement information by the seller to the buyer at the time the offer was made or prior to the offer being made, as part of that information exchange in there. And it kind of stiffened and specified how things had to be done. It couldn't be after their offer was made and the deal was, all the paperwork was signed, oh, by the way, there is a radon problem in the house. It had to be out front. And then in 2013, the Radon Resistant Construction Act was put in. And this one is another one of those that came from the industry professionals themselves. And it was a case where not the installers, but the real estate attorneys and others pushed for this to be put in, basically looking at all new homes must be constructed using techniques to reduce radon. And when we get down to looking at the passive radon pieces of it, I'll explain a little bit more about why that's significant. But they looked at it as a way to move the industry forward and overcome some of the issues we had in it. So next piece of this, and as that we look at this for over some time, the health implications. Radon and radon decay products are what you breathe in. If you've got a high radon concentration in a building, you breathe that in and you breathe back out the radon. But the part that stays in there are those radon decay products, basically alpha particles and other pieces that are floating around here. But the real issue is the alpha particles, and they get down in that lung tissue. They're trapped in the lung tissue and the bronchial epithelium, and those alpha particles have a lot of energy and they're bouncing around in there. They can strike those individual cells. They can actually pass into the cells, and they end up doing physical and or chemical damage to the DNA. It all depends on how they hit it and how they impact an individual cell. But that's where it becomes a problem, because it actually does damage internally. And to talk a little bit about how serious, or give you an idea of the impacts here, this is of 100-power magnification of a piece of hard plastic, basically the same type of plastic that would be in a traditional plastic eyewear, eye lenses. And what you're looking at is a piece that was polished, then was exposed for 3 months in a room that had 4 picocuries per liter in it, and you see the pitting that occurred. So if this stuff will pit plastic that badly, think about what it will do to the tissue inside your lungs. So as we look at it, what's been classified as the radon risk, as we look at it, radon is a Class A human carcinogen. It causes lung cancer, and has been recognized by a number of different institutions and different health bodies that are involved with cancer and cancer causing products or health issues. The leading cause, it is the leading cause of lung cancer for non-smokers and the number 2 cause for lung cancer overall. If you've got someone, they look at somebody's got that is a non-smoker and gets lung cancer, it's highly likely that this is the source. The radon exposure was the source for that. There's pretty significant numbers to back that up. US EPA, as of 2003, the assessment of it, and this is what pushed a lot of programming in this area. The risk from radon in homes was estimated to cause about 21,000 lung cancer deaths per year at that point. And in Illinois, using those numbers and the same process, it was estimated that 1,160 Illinois residents were at risk of developing radon-related lung cancer each year. And so that's when we started doing a lot of programming in it. I've been working with and presenting radon programming since about 2000. And so I've got 21 years in this, and we look back and there was work going on up to 3 years prior to that, or I should say up to 5 years prior to that, pretty easily. And so that's kind of why I asked that question. Is it still an issue? And when we look at it, that's the concern. So this action level, 4 picocuries per liter of radon in the air in a home is what's referred to as the action level. Now, why do we call it an action level and not an exposure limit or something like that? Is that when the US EPA looked at this, it was selected because with the technology and the economics that we had at that point in time, that was a level which they felt like it could be lowered down to and significantly reduce the risk to a point that was better than what we were at prior to that. So if we look at that risk and where it's not an exposure limit, at 4 picocuries per liter, the risk is about 7 people out of 1,000 will get lung cancer with continuous exposure at 4 picocuries per liter. So that's where it's a risk, and that's where we build things off of. So let's talk a little bit about where we're at today. In Illinois, there are over 5 million housing units. At this point, about 150,000 homes have been tested. Now, those housing units include apartments and high-rise apartments, condominiums, that kind of stuff in larger buildings where they're up off the ground, which aren't part of the, or are part of the number, but not necessarily part of the numbers that need to be tested. But what we're at is there's still a pretty significant gap between the number of homes out there and the number of homes that have been tested. When we look at indoor radon concentration by county, the map you see here is the 2014 one. Unfortunately, I have seen the 2016 one, but was not able to get a hold of a copy of it. And the site that this was formerly posted on has been under some reconstruction for some time, and it's from the Illinois Emergency Management Agency, Illinois Emergency Management Agency, and their radon program, and they hopefully will post a new one soon. 41% of the homes tested statewide were above that 4 picocuries per liter. The real key is if you look at this, there are homes in every county in the state that have tested above the threshold, that 404 picocuries per liter level. And any of those in red, they're above 50% chance that there is a high level in those counties. In other words, over 50% of the homes tested in those counties were above the 4 picocuries per liter. This is why we're still talking about it. Again, looking at how many people have tested, how many homes are out there, and what our rate of testing, what our testing rates are showing us is the potential for it, or why we still want to talk about it and why we still encourage people to look into it. Pardon me. So how does it enter the home? I mean, here's where we start with the basics of where we should be concerned about it and how do we address the issue. Radon as a gas is that first piece that's trying to rise up out of the soil. It's a gas, therefore it is trying to rise up out of the soil. Think of soil as a fairly solid area. You know, as a gas, its home is up in the atmosphere, not down in the soil. It enters our homes through openings between the building and the soil. So anywhere that there is a building sitting on the ground and there are openings for it to come out of the soil into the building, that's where we're getting it into our building. So we've got this natural breakdown from uranium to radium to radon. And if we think about it, our homes are nothing more than large vacuums sitting on the ground. Most of this is driven by the pressure differences, air pressure differentials between the building and the outside. Right now, up in Northwest Illinois, and most of us here in Illinois, we've got a low pressure system coming in to the area, bringing some change in the weather. That low pressure means that the ground has found some natural pressure prior to this. As that comes in and our pressure above it drops away, that gas is going to be trying to rise up and out of there. We're in the middle of the winter. We're heating our homes. We've got natural heat causes air to rise itself. So we've got air coming up out of the basement as it gets warm, trying to move upward into the upper part of the building. We may be losing a little bit of air through leaks and stuff like that through either the windows or the attic. So you've got this natural convective current that's pulling it into the building. So common areas where we're looking at it probably entering in, most significant places where it's entering into pardon me, where it's entering to the building are looking at foundation wall joints. Sure, we would come in and put a seal in there to start with, but over time that seal can break down, especially with a little bit of house movement. Anytime you've got over a crawl space, we've got open ground underneath and in a contained area, enclosed area. So what's above it? The open floor, that's moisture being pulled and air being pulled up in from. Sump pits, cracks in floors, concrete floors, and any utility penetrations are all places where it could be coming into the building. So how do we know whether we've got a radon problem or not? Well, the best place to do this is by testing it. So we'll talk a little bit about testing. What I'd like to know, and if Aaron will launch the first poll, I'd appreciate it. Has your house been tested before? Just like to know if you would click on and give me a response on that. Always kind of interesting for me to know what group it is, and I say that as a joke with some of them. A lot of times I come into like this where a large percentage of people have not tested the home. I had one meeting where everybody had tested their home, and so I kind of had to change directions here a little bit. So at that, looks like a good number of you have not. So thank you. Okay. So let's talk a little bit about this. Who can test the home? It's fairly easy to test. It's fairly inexpensive. Especially if you do it yourself. The determination on who can test the home is the occupant of the dwelling can test that dwelling. If you're the owner of the home, you can test, and you live in the building, you test it. If you're renting a home, the individuals in the home need to be the one to test it, not the owner. Doesn't mean you can't supply them with the kit, but they actually have to be the one to go through the process. Test kits are available from hardware and department stores, and they're also available from a number of the directly from a number of the laboratories. We'll share a link to the IEMA radon page, and one of the things they've got is a really nice link to the current laboratories that will send you a test kit for a nominal fee, and you can test it. There's also a ongoing program that many of the local health departments and some of the extension offices collaborate on, where they've got access to, as part of the training process, access to some kits, and those kits are available. You can pick them up at basically cost. And when you pick those up, they are already paid for. You mail them back in and get the information back. You can also go to a licensed measurement professional or their technician, someone who works under them. And that's a good way to go if you're involved in a real estate contract. We'll talk about that in a minute. No, one of the things that it is in the best interest of the buyer and a seller to rely on a radon measurement professional to do that test in the middle of a real estate contract, rather than having one or the other of them do it, because you always have the question concerned, did they do it correctly? So if we think about it, what is a radon test? What is recommended by Illinois Emergency Management Illinois Emergency Management Agency, always mess that up, agency, US EPA, and of course by extension as well, is we do a short-term test. We think about short-term test being kind of an initial screening. By definition, a short-term test is less than 90 days, and most of these are on average somewhere in the 2 to 7 day range. And that depends a little bit on what test kit and the protocol the lab recommends with that. But there's a number of kits out there that are in that 2 to 7 day range that are available. And that gives you that nice short-term piece of it. And think about this as being like taking your blood pressure. It's not a definitive answer, but it is a quick check to see if there's a red flag of needing to look more into it. So what do you test? You test the footprint of the building, which means you test each foundation type that is in direct contact with the soil or other materials, or directly above the soil. Measurements should be made at each of the lowest structural areas suitable for occupancy in those different zones, whether you've got a basement, a slab on grade, or over a crawl space. If you look at the picture there on the right, there is a basement. We've got a living area here that's over a crawl space, and apparently an add-on that is above is a slab on grade. So in technicality, you would need to test all three of these pieces, these locations, to get an accurate result. Make sure you don't have a problem in one of them and not the other two. So other part of this is measurements should be done in specific rooms, and they are rooms that are regularly occupied. Things like family rooms, living rooms, dens, playrooms, bedrooms, offices, those kinds of areas. Maybe the better thing to do is to talk about places you don't want to test. And those are your high humidity areas, things like kitchens, laundry rooms, and bathrooms. And that has to do with the type of test that most of these are. If you're using the activated charcoal test, the moisture interferes with interferes with the substrate in there and gives you inaccurate results. Other places you don't want to test are enclosed areas, closets, cupboards, sumps, crawl spaces, or nooks in the foundation. And these are areas that are going to trap and maybe have a little bit more of a concentration, and they don't give you a good picture of what's the average across the air. And think about it this way. You don't spend all days with your head stuck in a cupboard. are in the closet. And so that doesn't give you a good picture of what's the airspace where you're breathing. Because what we're worried about is the space where you're breathing most of the time. Stay away from those things where we talked about the testing and setting a test kit in a location that is near one of the entry points, such as a crawl space or in the crawl space, on a floor or right beside of a wall or wall crack. If you see a crack in the floor or a crack in the wall or right against the edge of where you see a foundation and the wall is separated a little bit, don't put the test kit right there, because that gives you what that incoming concentration is, not the concentration of the whole room. And also adjacent to sump pits or down in the sump pit. We've already said, yes, those are the entry places. What you're getting is the concentration coming in. You need to test under what's called closed house conditions. Short-term measurements should be tested in this way. And what you're looking for is to get what's that air in the building really like. For closed building, what we mean is the closed building, it needs to be the windows, doors, that kind of stuff closed up, not a lot of extraneous air exchanges in the 12 hours prior to the beginning of the test and during the test. And this is especially important for tests that last less than 4 days. And what that doesn't mean you can't come and go. It means the best times to test are really in the winter or in the summer. Spring and fall, you need to think about that and be really thoughtful about it, is because in the spring and fall, if we're opening the windows up during the day or during the night, then you're not getting an accurate reading, because you're actually changing the air in the building rather than what's being caught in the building and under that closed conditions at other points in time. So types of devices. There are a number of them out there, and this is some of the what we refer to as user short-term test kits that you can get. I would say the top 2 of them are probably the more common ones. One is the activated charcoal. This happens to be the one on the far left is the example of the test kits that IEMA has made available to those with the grant process through extension and through the health departments. And the motion of that reminds me, key piece of this, whenever you get that, be sure when you start the test to record the time and the date, and when you end the test, record the time and the date. Without those 2 pieces of information, the test is invalid, because they can't give you the time frame with which it was tested over and do the analysis with it. And that's a frequent problem that they run into with them. The bottom 2 of these are your a little bit more expensive test kits, and in some cases are the ones that you would go for a little longer time period, whether it be a 30-day or a 90-day. The Alpha Tracker, I've seen one of those that was set up to do, I believe it was between 120 and 180 days. And then you also can get one that's a full year test kit. Slightly different sizes, but they're set up to run that away. So they're a little more expensive to work with. But if you're looking for a little more accuracy or doing a retest, maybe worth looking at. Prices on these start between about $10, somewhere in the $8 to $10 range, and go up into $25, $30 range with some of the more expensive versions. The other type is what we call the continuous monitor systems. And these tend to be the ones that the professionals will use, because they're rather expensive equipment, where they'll come in and test, and they will do recordings continuously and collect that data. And what you may run across is, if you've got somebody testing, you have somebody come in and do a commercial test for you, they may install one of these and put one of those other test kits inside of it. They're required to do a check of their equipment ever so often. And sometimes what they'll do is they'll do it while they're doing a client home. Key things with a short, this initial screening short test, a minimum time for that is 48 hours. Exposure time for that is 48 hours. Basically need that much time to get enough data to get good results. And you also, that way you're not capturing an unusual blip in time. The air check kits, which again are available through IEMA and one of the places listed, key operative thing on those, they require a minimum of 72 hours. Theirs, they've got it down small enough, inexpensive enough. They want that longer exposure time to make sure that they collect a good representative sample. 72 hours up to a maximum of 7 days. So if you do a test and you get results back at above 4 picocuries per liter, the old now what? So, let you think about this for a second. So are we going to have to tear the house down? Or maybe we're going to have to do a total rebuild? No, here's the key things. And I put this in there because I have seen a couple examples. Oh, the radon level, you can't do anything but tear the house down and start over again. And the fact is that at least one example in a reality show where they said they did that and they built it right back on top of the foundation. If they didn't do some major work on the foundation, they didn't do anything about the radon problem. It can be fixed with it. What we just need to do is to work with it. So if the test comes back, consider doing a longer test or a professional test. So if you did a 3-day test, you might come back and do a full 7-day test. Or if it comes back just over 4 or kind of in that really low range, or it really comes back high and it's out of character for your area, you might do a retest just to see if that was there was something wrong in the test procedure, the weather got you and caused an unusual blip, something like that. IEMA does provide a list of radon mitigators and a list of radon professional test measurement professionals off their website. Point to that because it is county specific and it is a dynamic list. It is the one thing on their website that has continued to be current. You do have to go to the non-map version of it to get to that, but it is a printout sheet of all those folks. One of the things about both the mitigators, and the technicians and the measurement professionals, they have all had specific training and are licensed by IEMA. So that's the one reason we recommend those. These are individuals who have gone through the training, know what they should be doing, and recognize that in order to keep their license from one year to the next and continue to do business, they need to keep customers happy. And so that's one of the good pieces of it, is that you can file a complaint against them with IEMA, and basically the IEMA folks will talk to them about it, and they get too many complaints and their license won't be renewed. And here's a link to the IEMA site. And I also think that that Aaron has got that to send out, and it may have been updated. So we've done the measurement. What does it mean if we think we've got to do something to do about it? And it's referred to as radon reduction systems, because one of the things that's, and we talk about mitigation, it's not necessarily going to be dropping it to 0, but we can get it down to a tolerable level. Mitigation systems reduce the radon by essentially collecting the radon prior to its entering the home and discharging it above the highest eve. And the other way that we can do that, and the way that we do this in some of our commercial buildings, is to modify the building pressure. And that's where you're trying to put in, if you've got a public building where they have to do a certain amount of makeup air, or they have to add fresh air in, they're able to essentially pressurize the building rather than creating a vacuum on the building, and we can keep it out that way. So if we're talking about a home mitigation system, what we really are trying to do is what we call an active soil depressurization system. And this guide sheet is available to you. One of the easiest ways to do it is download it off the IEMA website, go into their list of publications. And an active soil depressurization system has a fan set into the system that will draw the radon from beneath the house and, let's say, discharge it above. You need to mitigate the entire footprint of the house. Had some early on, oh, well, just the crawl space or just the basement tested high. If one of them tested high, you need to capture the entire area. You need to do that crawl space as well, because there's the potential for things to shift and go from being underneath the building to underneath the basement or underneath the other areas and come up through that crawl space. If you've got a slab on grade, or this is actually how you do the basement depressurization as well, is what we call sub-slab. And they basically drill through the slab into what we hope is a gravel layer underneath there. You put a T into it or some type of structure that'll collect air, so you get air draw from the full footprint of that area and try to draw a vacuum on the floor. We're not talking about drawing a real strong vacuum, but a real low pressure vacuum. And then piping that material up and out. One of the key things of the fan is outside of the living space. In this case, the ideal place is to put it up in the rafters. So you're drawing it. And the key is that you're always pulling a vacuum on it. We don't want early on systems allowed to put the fan on the inside. One, you had a little bit of a sound opportunity there. The other part is that if somebody got disconnected, you end up pumping radon, especially above it. You end up pumping radon into the building instead of taking it out. So the submembrane depressurization is what you would use in a crawl space. Basically, with a crawl space, if you've got an issue with it, you need to put a soil gas retarder membrane down and seal it to the outer walls, to the foundation walls, and seal the joints in it. And whenever you do that, you put a lot of times will do is put a piece of drain tile in there underneath it with a T in it, connect to that, and then they can basically draw a vacuum underneath that membrane and pull the moisture up and out. And what this does, kind of a side benefit, is it tends to pull some of the moisture up and out of either one of those areas. Lowers that, and we basically are lowering that pressure underneath the soil, underneath the membrane, and underneath the house, and getting it up and out. So now we've got a higher pressure inside the house than we've got drawn on the soil. So radon resistant new construction, same theory. Basically what we're looking at most of the time doing is it's a passive sub-slab depressurization system. Same thing as the active system, except you notice the fan is not mounted in here. And the advantage here is it's designed into the building and part of the construction. And this is where we came into the problem with them in the previous runs of it. There wasn't a definite space to put that in where you run it through the inside, and they end up having to put the fan and the piping to the outside of it. So after you spend all this time looking at the aesthetics of a building, it ends up that it's not, you end up having to put this pipe on the outside and messing it up. So If you're thinking about building a new home, there are a couple of guides out there. The short one from IEMA, the handout there is a pamphlet that talks about the design of it. At this point, it should be part of the building codes, and most contractors should know about it. The US EPA put out a really nice building guide, and part of these pictures that we were looking at were actually out of the US EPA building guide, and then were reused in the IEMA training for their contractors. So there is a way to map that out, and you can look at it. So few key pieces to keep in mind here. Primary suction point should be different from the sump. Some of the early ones we were running through the sump. The problem was about the time you get everything put in, the sump pump goes out, plumber comes out, things are flooding. They put a new sump pump in and get it pumped down, trying to make sure everything's working, and they don't end up sealing things back up. Key things here: separate independent pickup point, as you see here, the two arrows, and also the sump pump cover has a cover on it and it's been sealed down. Discharge point needs to be up above it needs to be above the lowest, above the highest eave of the home and close to the ridge line as possible. Needs to be at least 10 measurable feet from any window or door, and 2 feet, anything that's less than 2 feet below it, that exhaust point, it needs to be 10 feet from it. Basically what we're trying to do is not create a situation where you're pulling that up and out and then turn around and drawing it back into the house when the windows are open. Also 10 feet or more from any opening of an adjacent building, and again above any windows there. No fair pumping it out and into your neighbor's bedroom window, upstairs bedroom window. Ventilation fan, the radon fan placement can be in the attic. Ideally, attic place is a good place to put it. Keeps it sheltered, gets it up above the house in the living space. Garages where there is not a heated and cooled living space above the garage, you can put it in that garage, or on the exterior of a building. Again, come back. These two pictures are both examples of where the passive construction piece came in. Very nice houses, new construction, all designed out, tested it after the building was built, and needed to have a radon reduction system installed. There was no clear pathway to run the reduction pipes from the basement, lowest level, all the way up through the ceiling. So they had to take it to the outside. And so after having done some litigation with some of this, the real estate attorneys proposed this, were in favor of it, and helped propose the passive construction process. I'll talk a little bit more about that in a minute. Monitors and labeling. The system needs a monitor, and a simple, very simple manometer is a good way to do it. And what you're looking at is that there is a little bit of a vacuum, that the outside pressure is higher than the pressure in that pipe. That tells you that the system is working and that it is pulling air up and out and drawing that vacuum that you need. Also labeling, and this labeling is really important as you go up through the building. Any joints, any place where somebody could open it up and mistake it for a drain stack pipe, because you don't want to hook your drain stack pipes into that, or somebody thinking it's a drain and dumping water down into it. Either one is a problem. So they'll go in and put these radon reduction system labels on it at various locations. Kind of the system details. Should effectively reduce the radon. Needs to be tested afterwards. Should be unobtrusive and permanent. Should be quiet. Yes, that fan runs continuously. One of the most expensive pieces of a passive or an active system is the fan. And you notice those rubber bushings on that. It's all installed to keep that quiet and long running fan in there. Include a system function indicator, primary suction point independent from the pit, sump cover, any sump pump cover, sump areas should be covered, and exhaust above the highest eve of the roof and as close to the roof line as possible. So is the mitigation system working? Once the system has been installed and activated, let it run for a few days, come in and test the building. That's the only way to ensure that it's actually functioning and doing what it's supposed to be doing. In accomplishing what your goal. And it's significant in that not every system works like it's supposed to start with, and sometimes it has to come back and be tweaked. Maybe they have to put a second draw point on it because there's not what they call communications underneath the slab. You want to test in the same place you initially tested so that you're comparing apples to apples with it is the best thing. Again, in that closed door condition, closed house condition, use the other testing protocols the same as you did before. The other piece of this is recommend that individuals come in and test their home every 3 years, plus or minus a season or two. As I say, all homes should be tested. The only way to know if you got a radon problem is to test it. Even those that are built with radon resistant features can still have a radon problem. The nice thing about it is if you still have a radon problem at that point, you can connect, you can actually go back in, put the fan in it, and all you've got to do is put that fan in. You don't have all the other construction pieces to do it. It makes it much cheaper. What the attorneys looked at with respect to that I didn't include earlier was what they figured was that in putting it in initially, there's about at most $500 worth of materials in it. Probably more, probably less than that. Materials and time put in it. But if you have to go back and put it in, you end up putting it to the outside and having the problems with it. So it, as I say, it reduces that aesthetics issue of having to go outside with it. So here is the contact information for me and for Patrick Daniels, who I need to acknowledge provided a lot of the pictures and stuff that I have as well. We may share back and forth to be consistent about some of this stuff. So with that, Aaron, if you'll launch that last poll. And we can start answering some of the questions, because I saw the chat box moving rather quickly.
All right, thank you so much, Jay, for a really informative presentation. We did have a number of questions. So first, there were quite a few questions about testing. So if you have a basement, should you test the living spaces above the basement or just the basement?
You should test the basement. Under normal conditions, radon is a little bit of a heavier gas, and so it will remain in the higher concentrations, will remain in the lower spaces. Now, one of the key things about your testing the basement is it a finished and occupiable space? And if it's not finished and or could be finished and occupied, then you're not spending very much time down there, then testing the rooms above is appropriate. I always get to ask that question of, okay, we don't spend very much time in the basement, or we don't do anything in the basement. The only thing that's in the basement is my washer and dryer. In those cases, you probably don't need to test it. And a lot of individuals said, well, we don't use the basement, and I'm worried about the upper floor. They'll test the basement. He comes back maybe a little bit high. They'll come back and test the upper floor and say, well, basically, as the question says here, I plan on remaining the upper floor, staying upstairs. Well, that's not a bad plan and letting somebody else handle it next. In that's an option for you. It's two things we're looking at is one, for somebody who's going to be using the basement, and how much time you're spending in an area. That's what we're really trying to test.
Okay, great. We had a couple questions about garages. If you should test if you have an attached garage, or also if you have an unattached garage. Do you test in either of those locations?
In essence, you would not, unless the garage actually doubles as your office, a business facility, workshop that you're in constantly, something like that. Again, is it an occupied space?
Okay, great. Someone asked if you can run a fireplace while testing your home.
You can. The thing that I would say with that is it something that you run quite frequently? In other words, if one of your primary heat sources is a fireplace or one of the corn stoves, a potbelly stove in the middle of the floor, and that's a good portion of your heat, and you run it constantly, yes. If it's a fireplace and you only run it occasionally, more for atmosphere than heating, I wouldn't run it during that because it can create an extra draw in there. To back that up, I will say my house, when I purchased it has two fireplaces. One is in the lower level. I think that the lady that was living in here lit the fireplace the last 8 hours of the test, and it resulted in a pretty good spike in radon coming into my into it, because mine was running about around 4 to 5, and then it jumped to 20 in that last 8 hours overnight, and it was pretty cool that night.
Okay, thank you. Someone asked if your house was tested years ago, then should you repeat the test periodically? So I guess what sort of timeline should you look at if you get a test?
The standing recommendation for all homes is 3 years plus or minus a season. And some people are actually talking about 2 years, but the older recommendation is a minimum of 3 years.
Okay.
Ideally, it's 2 years and 3 seasons, so you're always shortening it.
Great. Someone asked if there's a way to see if their house was tested in the past. I'm guessing like some sort of record that's available to check.
The only ones that are out there that are attached to an address would be to contact Patrick Daniels and see if there is a professional record of it.
Okay, great. Is the 3-year retest recommendation assuming that you don't have any mitigation equipment in place? So like if it tested at normal levels?
No, and in fact, the 3-year test is recommended probably stronger for those homes in areas where radon is a little higher, more prevalent, and they're home tested okay the first time. Because think about it, what drives that? You've got uranium down in somewhere deep in the soil, and it's working its way upward. Those cracks, we have a little earthquake, things dry out, we get really wet. There's a certain amount of movement in there. So you may not have had a crack, an opening coming up from deep down previously. Over time, now it's opened up and coming in underneath your slab or underneath your crawl space. That's why we talk about that 3-year retest, because things are always changing.
Okay, great. We had a couple people who were mentioning that they have mitigation systems installed and that the system tells them to call a number when it gets to a specific mark, so a specific level. And when they've called the number, no one returns. So no one returns their call. So they're asking if mitigation companies are required to address or advise in these types of issues.
Yes, and when you, and I guess I would ask for a little bit of clarification. Are you talking about that if they do a retest and it gets to a certain number, or if the manometer gets to a certain number? If it's the indicator system, what some
That's
of
what
the
I'm
system,
assuming, yeah.
yeah, some if on some of them, if the mitigation system is equal, if you look at a manometer and they're equal, that's a good time to that's a reason to call them. Call the installer and say, hey, something's not right. You've either the fan's gone out or it's lost its vacuum for some reason. The other one is they may be looking at needing to add a little bit more liquid, so that you always want to add a little bit to keep that liquid in there, because it will over time evaporate out, because most of it's a water-based marker.
Okay. If the number they're calling is not returning their call, is there any other number that they could call to get a response? It sounds like
The two things that I would suggest is, one, look at the list and see if there's another installer you could contact. Or number two,
okay.
give IEMA a call, give Patrick Daniels and his organization a call and ask them about it. If that installer is still in business, maybe they've changed numbers, or maybe they've handed their business off to somebody else and he may know that.
Okay, great, thank you. Let's see. Someone asked about what happens to the radon once it's released outside of your house. So if you have the mitigation system and it's going off the top of your roof, we assume it's safe at that point because it's not in our homes, but what happens to it?
It keeps rising and gets
Okay.
dispersed into the air. Same thing that would happen to it, happens to it coming off the soil in our backyards.
Okay, great. Someone asked about if you can walk on the membrane in the crawl space after it's installed. And I'm not quite sure which mitigation system that was referring
That
to.
would be the member would be under crawl space. And yes, you can. You need to be very careful about it. I would say if you were setting it up and you knew you were going to be moving around on it and intentionally on a regular basis, make sure the installer knows that and uses a little bit heavier material in that, maybe even leaves a little bit of slack in there for it to move a little bit as you step. The key thing is to make sure you don't break it. If you step down and you create a tear in it, you need to come back and patch that tear.
Okay, great. The last question that I see right now is, how serious is it if your sump pump is covered but not sealed?
All depends on how serious the radon issue is in the house and in the area.
Mm-hmm.
If it's unsealed and you don't have a radon problem in the house, it's probably okay. If you have a radon system and it is like the picture I showed, where the sump, the draw point is very close to that sump, really need to make sure that it's not drawing air from inside. I know that the sump is not, sump cover not being sealed down is not allowing a lot of house air to be drawn into there, and therefore short circuiting the system. Because remember, what you want that to do is to create a vacuum out across the whole floor. So if it's finding air and drawing air in there, you're not drawing that suction across the whole floor. And there it does become a pretty serious problem.
All right, thank you so much for answering all of those questions, Jay. That's all that we have in the chat box right now, and we are 1 minute away. Oh, right at 2 o'clock. So thank you.